In this video, we're going to consider positive and negative cubic functions. So we'll start off, we'll consider the function y equals 3x cubed plus 2x squared minus 5x. So just before I run the animation, we'll just see what you think is going to happen. So obviously in this section here, we have a positive gradient at all points. Now what's going to happen at the gradient, you'll see as we start down here, the gradient's 50. So therefore, it's going to be plotted way up here. And what's going to happen as we tend towards the vertex here, is you see the gradient becomes less and less steep. So the value is going to decrease until we get to -1 here, where the gradient is in fact 0. So therefore the gradient graph will be represented. We expect it to go through an x-intercept at -1. The gradient then is negative between the two turning points. The interesting thing you'll see what will happen here is it's going to be 0 here, and then it's going to start to get more and more negative until halfway between the two turning points it will reach its most negative value. And then as you tend towards the turning point again, it's going to become less and less steep again, so less and less negative until you get to the vertex, which it will be 0 again. And then we have a positive gradient, as in this section as we go from left to right. The gradient is going to increase, so therefore the line is going to go up. So if I just run the animation here, we won't see the gradient yet because it's such big values here, you see. But once we get down to a gradient of 8, we'll start to see the gradient function coming down here. So we'll see it coming above the axis here, and you'll see at the vertex the gradient is going to be 0, so the gradient function will go through. So halfway between the two turning points here, you're going to see the steepest part of the gradient. So at this point that's halfway, and then what will happen to the gradient, if you look at the numerical value here, it starts to get less and less, and then until we get to 0, and then it's just going to keep on increasing as we go from left to right. Therefore, when you derive a cubic function, you'll see that we get a parabola, quadratic function. Now to consider a negative cubic function, put in the function here negative 2x cubed plus 5x squared plus 2x minus 3. So again, just quickly, what we expect to happen is, in this section here, we are going to have a negative gradient. So that means that this section here is going to appear below the axis. What's happening to the negative gradient as we tend towards the turning point is it's getting less and less until it hits 0. Again then, we're going to have two turning points here. So we're going to have points of 0 gradient on the axis at these points. Again, the gradient between the turning points in this section here is going to be positive. And it's going to be at its most positive halfway between the two turning points. So that's where we're going to see the peak. As we then go towards the turning point again, it is then going to lessen. In this section here, we'd expect the gradient to be negative. And as we go from left to right in this section, it's going to become steeper. So it's going to become, the greatest values will be to the right, the greatest negative values. So if I just run the animation here, we'll see the gradient graph. Okay, so again, we got a large negative gradient here, -15, so we're not going to see it until we're coming up. So again, here we're going to see the gradient coming up, and then at the vertex, you see, it's going to go through the x-axis. Now, between these two turning points, that's where we're going to see the steepest gradient, the steepest positive gradient here. And then it's going to start to decrease. The gradient is going to start to decrease as we're going towards this point of 0 gradient. Okay, so you'll see at the point of 0 gradient, that's where it's going to pass through the axis. And then the gradient's going to become steeper and steeper negative as we go from left to right. Therefore, you see here, when we differentiate a negative cubic, it's always going to return a negative quadratic.